Okay, so today I'm going to talk about halogen derivatives. So this is actually a first chapter in 12th standard SSC board. So let's first understand the meaning of halogen derivative. Here I have written, first of all, what do you mean by halogen? Halogen can be broken into two parts. First means halo, it is a Greek word. Halo means salt and gen means to produce. So halogens are those compounds which actually form salts when they react with metal. That's the reason they are called as halogen. And here they are placed in periodic table in group 17. You can see few examples of halogen: fluorine, chlorine, bromine, iodine. They are called as halogen atoms. And in this chapter, we are going to talk about halogen derivatives. But what do you mean by derivatives? So actually, derivatives are also a family of compounds, organic compounds, but they are derived from hydrocarbons. Here I have shown hydrocarbons. And what do you mean by hydrocarbon? You have learned this term in your earlier standards. Hydrocarbon can be again broken down into two pieces. Hydro means hydrogen and carbon means actually carbon. So they are the compounds containing only hydrogen and carbon. You might have learned alkanes, alkenes, alkynes in your earlier standard. They were all examples of hydrocarbon. But in this part, we are moving just a step ahead. We are going to learn derivative of hydrocarbons. So now what do you mean by derivative? What we actually do to form a derivative, what we do is we just replace a hydrogen atom. Here you can see I have drawn, we have to just replace a hydrogen atom by whom we are making a halogen derivative. So yes, we have to replace it with halogen atoms. Now, halogen atoms can be anything: chlorine, bromine, iodine, fluorine, and which in which atoms they would be replaced or in which compounds they would be replaced. You can take any example like aliphatic or aromatic. Now, what do you mean by aliphatic and aromatic? Again, we have done it in earlier classes, but I will just give a glimpse on that. Aliphatic compounds are just straight chain compounds, are cyclic compounds, but aromatic compounds are special compounds which have benzoid kind of ring structure present in it, which is a six-membered unsaturated conjugated ring structure. Okay, so now let's learn about halogen derivatives more, in which we are going to first learn about classification. Now, there are two ways to classify halogen derivatives. The first one is actually based upon hydrocarbon skeleton. Now, it means like what you have in the compound. The first type is actually haloalkanes. Now, as the name suggests, it has a halogen, and the halogen atom is actually brought into or substituted into alkanes in place of hydrogen. So here you can see an example. This was actually an example of an ethane in which one of the hydrogen was substituted by a halogen compound. If it is a chlorine, then it would be a chloroethane. And similarly, if you can take any other halogen compound, you get respective halogen derivative. Another is haloalkene. So again, as the name suggests, this is an ethene in which one of the hydrogen is substituted by halogen. Same way, haloalkynes. So alkyne means the compound which has C triple bond C. This is again a simple example which is of ethyne, and in that hydrogen is substituted by a halogen. And this is a special kind of compounds which is called as haloarenes, in which a halogen is directly attached to an arene, or else you can say aromatic ring. Okay, this was the first classification based upon what is the hydrocarbon skeleton. Now, there is another way of classifying, but now this is based upon how many number of halogen atoms does a compound has. So now the first type is monohalogen. Now, as the name suggests, mono means what? Mono means one. So if your compound has only one halogen atom, okay, I'm repeating, if your compound has only one halogen atom present in it, like you can see here in an example, again, in which ethane is substituted, one hydrogen is substituted in it by an halogen. Similarly, this one, only one halogen is present. So they are classified into category called as monohalogens. So similarly, di means two. So in this kind of compounds, you should have two halogen atoms. So, but they can be placed in either way. So in the first example, what you see, both the halogen atoms are placed on one carbon, like two hydrogens are substituted from the same carbon itself. That is also fine. Or both the halogen atoms are placed on two different carbons, like they have substituted hydrogens from two different carbons. And similarly here also, this was dihalogen compounds. And now you can guess for trihalogen yourself, right? Tri means three, and as you can see in the example, there are three halogen compounds attached. Here I have taken example of propane, in which it already has three carbons, and all the three carbons, each one hydrogen from all those three carbons is substituted by a halogen. This is also a general example of an aromatic ring attached with three halogen atoms. So this was the classification based upon number of halogen atoms. Hope all of you have understood it. So there were two ways of classification, hydrocarbon skeleton, and another was number of halogen atoms. Now this was a more generalized classification, like we are going into mono, di, tri, and here we are going into alkane, alkene, alkyne, arenes. But a more detailed classification is only there for monohalogen now. Okay, now let's see how do you classify monohalogen compounds. Okay, so overall this classification has six types of compounds, monohalogen compounds, and all these are based on either the position of halogen atom or to the type of carbon, or you can say the hybridization of the carbon to which that halogen is attached. Okay, remember that two things are important: position of halogen atom and hybridization of carbon to which our halogen atom is attached. I hope these two things are clear. You have to remember it very carefully. So let's go with the first one. The first one is alkyl halides or haloalkanes. So now in this, you can see I have written in one line. This line is very important to remember, that your halogen atom will be bonded to sp3 hybridized carbon. You might have studied this before, different hybridizations. There are like sp3, sp2, sp. I will not go into detail. I would just write sp3 hybridized carbons, or the compound which has all the carbons of sp3 hybridizations. They would be saturated. Okay. You won't find any double bond or a triple bond in it. Okay. So here we can see an example. So here this carbon, if I just replace this R with suppose another CH3, this CH2 has a halogen attached to it, and this CH2 is attached to only one carbon. When this happens, okay, the carbon to which halogen is attached to only one carbon. It is called as primary halide, or you can say 1-degree halide, since this carbon is called as 1-degree carbon. So now what happens if your carbon which is attached to halogen is attached to two carbons? If I just remove this R groups and substitute it with the two CH3 groups. So now this carbon is actually attached to two two CH3s, or I can say two carbons. So it will be called as 2-degree carbon, and your halide will be called as secondary halide or 2-degree halide. So now what happens if I say our halogen attached carbon is further attached to three different carbons, then the compound will be classified into tertiary halide or a 3-degree halide. So hope this is clear. First of all, what is sp3 hybridized carbon? Sp3 hybridized carbons are those carbons which have all the bonds in the form of single bonds. They don't have double or triple bonds. Okay, they are like saturated carbons. Whole compound will be saturated if it has all the carbons as sp3 hybridized carbons. So it is classified into three types: primary, secondary, tertiary. Based upon what? Based upon the carbon to which your halogen is attached. If that carbon links to one carbon, then it is 1 degree. If it is linking to two carbons, then it is 2 degree. If it is linking to three carbon, 3 degree. Similarly, there are other ways also. Next classification is allylic halide. And here I have written again our halogen is bonded to sp3 hybridized carbon. But now there is a twist here. Now, what is the twist here? This sp3 uh, carbon is actually adjacent to C double bond C group. Here you can see this is a C double bond C group, and this is a carbon which is adjacent to that C double bond C group, and it has halogen attached to it. Okay, so first of all, this carbon itself is called as allylic carbon. We should remember this term. It is called as allylic carbon. So obviously, a halide or a halogen attached to that carbon will be called as allylic halide. So example can be found in straight chain compound also. This carbon is again an allylic carbon, or in ring compound also. There are few more classification ways like benzylic halides, vinylic halides, haloalkanes, aryl halides, which can be discussed further. But for the time being, I will be discussing only this much. Hope this much is clear, and we can discuss more sometime later. Okay, thank you.